So good afternoon, ladies and gentlemen. We are Project Raphael. We are a team of two. I'm Harris, and he is Data. I graduated in computer science in Hong Kong U, and I was one of the founding members in the Innovation Center of Cathay Pacific Airways. And Data graduated in PhD of Physics in Hong Kong U, and he is the founder of the 3D printer manufacturing company. So the Project Raphael is the second venture of us. We are now in two accelerator programs in Hong Kong and in Barcelona respectively. So inspection is something that you never know it's happening until issues happen, like the Martha White building collapse in 2010, and the Amtrak train derailment in 2015, the plane crash in Miami in 2005. So all of these accidents happened due to the improper inspection and maintenance. We don't want to see this tragic accident happen again. So you may question why inspection does not work well, because the majority of the primary judgment are still done by the visual and manual inspection. To tackle this problem, two factors have to be taken into account to address: quality and frequency. To increase the quality, we must reduce the human errors. To increase the frequency, we must reduce the cost and time. The human errors can be minimized by adopting automation and adding more sensors to get a better quality of inspection, while the efforts spent on cost and time can be optimized by drone. That's why we come up with this topic. And our vision is to build an intelligent inspection to save people's lives and make people's lives easier. That means a better safety and higher efficiency. So let me give you an example to illustrate further about how long it takes and how much it costs. In building inspection, a team of engineers roughly take 10 days at a cost of 150 million annually for the company cost. And in train inspection, roughly 4 hours on average at a cost of 148 million. For aircraft inspection, a team of engineers roughly take 15 minutes for every landed flight at a cost of 346 million. So what we are proposing is a solution that can drastically reduce cost and time. We can save 90% of time in building inspection, 80% in train, and 80% in aircraft. While in cost-wise, 90% drop in building inspection, 36% of saving, and 50% of saving in aircraft inspection. So we propose to use the HD camera and 3 different sensors, namely the infrared sensor, lidar sensor, and sonar sensors for inspection. So we can apply the drone inspection service across different industry and sectors. And we are now actively engaged with Siemens and MTR to step our first footprints in the rail inspection. Market size is huge, 67.5 billion globally and 82.5 million locally. And our target users are inspectors, engineers, and project owners. So because time is limited, so we can just use one example to illustrate further, the building inspection. So users can define a path of waypoints for autonomous flight by using sonar sensor. And we have the lidar sensor, the 3D sensor, to construct the 3D mapping in real time and use the 3D model to do the measurements, like the length and depth. We use the infrared measurements sensor to do the water leakage and the surface cracking, and we synchronize all the inspection data across different parties and let them review the inspection history. So let us give you a very quick demo of what we have done. So thank you.
Thank you. Now, I want to know more about the compatibility. Obviously, if you can incorporate a range of sensors beyond infrared, beyond just a standard one, a new from optical to microwave to ultra to X-ray, can you do that?
Because what we are doing is not hardware, we're focusing on software.
Yes.
So all the hardware products are off-shelf product, like buying from DJI and all these kinds.
Good to hear that. So therefore, my question is actually, what exactly is the strength here? Is
our software, like the algorithm behind, like if we can do the measurement, length measurement and depth measurement in real time, so we can do it right away. So we can remote control the drone and do the measurements in real time. And we file the reporting stuff back to engineers and they can do the inspection and get all the details in real time.
So that's not a problem?
Yeah, that's not a problem.
Okay.
I can understand your value proposition when you talk about building facade because you fly up.
Right.
What about rail and aircraft?
Rails, we inspect the rails by using sonar and visual inspection. Right now, the MTR engineers have to take like every 3 days. They have to inspect manually. So they have to walk through all the 220 kilometers rails every operation, 20 teams parallel run together. So what we are doing right now, we can use the drone to fly along the roads and do the visual inspection and the sonar instead of done by manual inspection, manual visual inspection. So in aircraft, same case. They just pass by, walk around the aircraft, visually inspect. Is there any defects, new defects happening? So what we are proposing, we would like to use the drone to fly up at a certain heights, and then we can inspect manually, and then do all the reporting stuff. Because the second pain point to the aircraft company is that they have to file so many reports and to do all kinds of annotation and to centralize all these, but we can do it in one go, just a few clicks.
So what is the technical barrier of your company? I mean, it seems like it's mostly a business model, right?
Yeah, because our prototype is just, we have done the 3D sensor part, visual inspection, 3D sensor. We have integrated like the 3D model, the length, depth measurements, but we haven't yet integrated infrared and the sonar sensor. So upcoming the second phase and third phase. So
how
we
about
will
software? Any, if
software we haven't yet done. We have just focused on, because this is just a prototype, and we focus on the 3D modeling stuff at this time.
So what is the key for your company to be successful?
Because our focus is a multi-sensory, and as mentioned, we want to do a multi-sensory instead of just a visual inspection. So the key is to integrate it, all kinds of sensor in real time, and the engineers can do the judgment in one go instead of like processing and get the data feeds and get the inspection result.
Actually, I agree. I like the idea of integration and multisensory, but I just don't have the confidence. I don't have the evidence. So I say that you can do it.
I see.
I just don't. Can you tell me something that you can do it?
As mentioned, we have done the visual, but the infrared one, we have do the a minor prototype about like we basically use the infrared to track the surface, the building.
Good. Say I'll give an example. For example, I want to do a dumping ground. I want the drone to fly over it and collect real-time data, chemical analysis, air quality, etc., and toxins and fumes, etc. Can you do that?
Our roadmap hasn't yet been done, like the toxin stuff. We're just focusing on the infrared, but of course we can extend to different kinds of sensor. You mentioned about the capability of our team. We are quite confident on that. I have extensive hands-on experience on software development, while data are on hardware. So,
I'm also, for my PhD, I'm specialized in processing the signal from the semiconductor, measuring the semiconductor defect. So for the signal from X-ray or gamma wave and infrared, I'm specialized in that signal processing signal processing.
So your business model is providing the service or selling?
We're selling this solution, so software solution. So to provide this drone service, we are now partner with a team of drone pilots. Thank you.